Hi, I'm Alberto from CSCS, and in this video I wanted to show you how we can flexibly run containers using MPI with the Sarus container engine. I'm gonna use an image featuring the OZU Micro Benchmarks, a suite of programs to evaluate the performance of MPI implementations and network hardware. The image is built starting from the official CUDA 11.3.0 image on CentOS and adding MPI 3.1.4 and the OZU Micro Benchmarks, both compiled from source. The benchmark suite is also configured with CUDA integration, and the Docker file defines a custom working directory for convenience of use. I have already pulled the image into the system, so I can call Sarus run through the workload manager, which on this system is Slurm. I am going to use the OZU latency test, which performs a series of ping-pong communication between two processes and reports the latency for different message sizes. Before running, I must ensure that the host MPI launcher and the MPI libraries in the image are able to communicate between each other using the same PMI implementation. The MPI libraries in the image use PMI2, so I add an option to the Slurm workload manager to specify the usage of PMI2 also from the MPI launcher. In this way, I can run a container as it is, using the full software stack from the image. However, I'm running on a Cray XC50 supercomputer, and this latency performance is well below what the network hardware can actually deliver. The image I'm using contains an MPI implementation which is ABI compatible with the native MPI libraries provided by the system vendor. When ABI compatibility is satisfied, I can use the --MPI option of Sarus so that the image MPI is seamlessly replaced with the host implementation, allowing the container to achieve native performance. Since the native libraries are going to use Cray-specific interfaces, I do not need the option about PMI2 anymore. Running the container again, I can see that the latency is much lower and is now on par with the native values of the Cray Areas interconnect. But the advantage of having the host MPI libraries inside containers do not stop at performance. For example, we have access to additional features which may not have been supported by the original image MPI, like RDMA between GPU devices through the NVIDIA GPU Direct technology. To demonstrate this feature, I need to define an additional environment variable called MPI RDMA enabled CUDA. And add a utility program from the OZU Benchmarks suite. This getLocalRank utility is only necessary because of the way these benchmark programs are implemented and is not a general requirement. I also add command line arguments to OZU latency to specify I want to use the CUDA transport and to perform device-to-device communication. I launch the container and I see that I am effectively executing an MPI CUDA program with direct data transfers between device buffers. So we have seen that Sarus gives us the flexibility to run MPI containers either with the original image software or with the native host libraries for increased performance and features.